Hello?
Hello.
Hi, how are you?
I'm good, thank you. How are you?
Okay. Welcome.
Yeah, thank you.
Yeah. Why don't we wait? Oh, here comes someone else. Why don't we wait for a couple minutes and then we can do an introduction as to who you are and what your interests are and all that.
Sorry, could you repeat that?
You can wait for a couple minutes for people to show up and then you can do an introduction, like who you are and what your interests are and all that.
Okay.
Okay. Hi, Ash. Ash.
Hey Bradly, I just couldn't hear you. It was I just felt that there was some feedback thing or something.
Oh.
Oh, yeah, now too.
Is it okay now or? Okay. Anson, how are you?
Hello. Oh. Hello.
Hi, how are you?
Pretty okay. Had a good Thanksgiving.
Good.
Overall, been a relaxing week.
Good.
Is my video on?
Yeah, I can see it.
Okay. Can't see it on my end.
Okay.
I haven't made that much leeway on the A-Life and Artificial Consciousness paper, but there's been interesting leads.
Okay.
So the general layout of how I'm thinking about it now is on the artificial consciousness front, there seems to be different formulations of what the basic aspects of consciousness are, and then symbolic, what's the word? Connective, symbolic versus connectivist, and then hybrid models of what? The structure of consciousness. I think it'd be an obvious way forward for me to do it is to view it historically, probably just make like a quick timeline to summarize the main authors, which probably is a big endeavor, so I might have to like not cut corners, but do a very brief overview. And then on the A-Life front, my general approach would be to look into one artificial organisms and recent developments in that. I know that like this is slightly like this isn't recent, but I know that what's it called? Soft bodied organisms that move that are supposed to move, grow, and reproduce like plants. No, are something that's a recent development, which is interesting. That I want to look into. There's some stuff about like one author did like computational complexity in the fitness landscape, which I'm interested in. in general, I'm actually I actually don't understand complexity that well, so I think that definitely be a motivating factor for me to just grasp that so I can understand the literature. I definitely want to get a grasp on genetic algorithm. I know recently, see some guy, he's either a CEO or he works at Uber, developed a genetic algorithm that a version of the genetic algorithm that doesn't just focus on, I think, utilization, but also focus on diversity of outcomes. And that was a major paper that won awards in general, acclaim that I want to look into. I think similarly to the artificial consciousness route, I want to look into the general, a quick overview of the historical route. Obviously, I'll look into Varela. I think there's and early art and other early scientists in the field that were interested in creating artificial organisms and creating stuff like a genetic algorithm, just to have a clear tie-in to what the contemporary frontier of that research is now. Oh, I guess I should have asked before I just gave an update.
Oh no, this sounds good. So this is the outline for that paper you're talking about.
Yeah, the general outline from like cursory readings.
Yeah, I think that sounds good. I mean, there are some things that you can add in at each step. Like, I don't know how you're managing your literature review. Maybe like, you're using some sort of tool for managing references, or are you just kind of coming up with an outline with different topics sort of lined up?
I probably should use a tool. By default, it's probably going to be just like download PDFs, have them on the folder, and then make notes.
Yeah. I recommend, for like a paper of that scope, though, I recommend using some sort of reference manager. Like you could use Zotero or something like that. Basically, just to have everything in one place, so you can look through them and see. But whatever your personal style is that you're most comfortable with is good too. But just make sure that you have, you don't get mixed up with references, and make sure you tie like a reference to like what you're writing, so that you know what it is that goes with what, because sometimes it's a problem if you're making notes and you don't know which reference goes with which thing. But I think that sounds good. There's some things in there that you'd probably have to show me what you have in terms of the references for me to make suggestions, but there are a lot of suggestions I could make in terms of references for things. But I mean, it sounds like a good approach. The genetic algorithms one is particularly interesting. We've done some work on that, and that's one of my areas that I have a little bit of knowledge in. So, and I think there's a nice A-Life crossover there as well. A lot of the things you read on artificial intelligence don't really talk about A-Life as much. It's sort of a separate field, but I think it should be kind of brought together a little bit more closely, just simply because people think about like how does the brain work, but it's like, well, you have to think about things like evolution, you have to think about things like embodiment, you have to think about things like so and those are sorts of things that people in A-Life are doing. So
two things in the reading group that Jesse and I are in yesterday. We actually talked about like different explanations of time based off inactivist, the 4E perspectives, which is interesting. And in general, they want to know phenomena they want to go through the phenomenology textbook, which I'm actually kind of excited for. It's actually by Chamorro.
Okay.
The other thing is apparently, like, just how it turned out, I have 3 statistics and machine learning related final projects this semester. One is I think is going to build up my technical skills. One is, what I proposed is basically I'm going to categorize, like I'm pretty sure Project Gutenberg already has text, organized into different genres, but I'm going to build how I describe my project to him, my professor, a machine learning algorithm that's going to organize books based off their content into different genres. The other project is using Google's historical daily weather data that they provided from 80,000 stations. I'm going to use the variables in the data set to infer what weather condition, rainy, sunny, cloudy, etc., the days. So that'll be interesting. And the third one is in my software development course. Apparently our project is going to be baby detection, like baby chair detection. Like we're going to have photos. I think we're going to use so the product is you have a camera and it needs to be able to detect whether there is a baby chair in a car seat or not. Oh, yeah, gets a decent amount of experience with machine learning and stats this semester. Yeah.
It sounds like a set of projects.
Yeah.
So, hi Jesse.
Howdy.
So, first I wanted to say welcome to the meeting. We have a new person here, Gabrielle Smith. And why don't you introduce yourself, Gabrielle?
Hello. So I am an undergraduate student at the South Dakota School of Mines and Technology. I am currently pursuing degrees in math, biology, and science, technology, and society. My main background right now is actually in data analysis and math modeling, and my research interests are primarily in computational psychiatry, but sort of span across neuroscience, if that makes sense.
Yeah, it's good. Well, welcome. I hope you find these meetings useful. We usually have a diverse group of people with, basically interest in neuroscience, but it spans a lot of different areas of neuroscience. So, I think you'll find it interesting and useful. So, welcome. Ash, did you have anything to add? I know your connection's been a little bit.
It's been a while. I just came to the university campus, and then it took me some time to settle down with all these test results and stuff. And yeah, I'm just starting with my project right now. It's just we're currently going on with two of that. One is a review kind of thing, which doesn't have any experimental stuff, but the other one is an experimental stuff. So it's like a visual psychophysics kind of thing. So it's more of an experimental thing as such. So the data is collected. I will fix the one by a function over it, and then I do, and kind of very I'm so jam packed.
Yeah, well, thanks for the update. Glad to hear things are going well.
Did I lose something with the past, the 2 weeks?
Oh,
Something very important?
I'm not. Well, I did have a talk last week on. Can't remember what it is, but I'm going to talk a little bit later about how you can catch up with things. We made a little bit of an advancement in that area, so we'll talk about that in a little bit. But yeah, I mean, you haven't missed too much. We've been talking about different things, but
Okay.
yeah. So yeah, if you we'll talk about that in a minute. So Jesse, what did you have on the agenda today?
Yeah. Hello, everybody. Hello, new people, old people. Good to see everybody here. I'm Jesse. I'm I'm the lab manager. I deal with some administrative stuff for those who don't really know me. And if you have anybody has any ideas about projects they want to do, feel free to me or Bradley. We try to facilitate a lot of different things going on in the lab. And to that end, one of the things that I've been trying to do is help organize it more. And I'll show you the current project board for things. I can share my screen. Yeah. So I think you all can see this. Here's kind of here's a bit of an overview for our weekly lab meetings. We have some past stuff that we'll go over. We have some active projects. We have some new stuff. And I did by the way, just because I missed it, when I got here, there was a big discussion that Anson said, and I didn't know what was all that about because I came in the middle of something. So.
Oh, he was just talking about his outline for his paper. He's doing this paper on artificial intelligence and A-life.
Yeah.
Yeah.
Okay, that's cool. Let's talk about that again after Anson, because I know I've been encouraging some discussion about that. So yeah, and I know I mentioned citations and things like that, and we can use Zotero or some Google Docs related stuff for sure. We'll do that later. Yeah, what we talked about last week here is why is it loading on my screen? Oh, never mind. Sorry. Last week, one of the things we talked about was Bradley had this really great presentation called Thoughts on Developmental AI, which is kind of a follow-up of some various lens thought we've been having. So if you want to mention that at all, you can. And I kind of try to keep at least one thing from the previous meeting, so we can have a little bit of tie into our last stuff, because there's a lot of overlap, a lot of different trains of thought that are going on here. But that's something that between that and the note-taking conversation, those are sort of the things that happened last weekend. But yeah, did you want to say anything about that, or just kind of mention it?
Well,
just let people know.
I was last week. I did sort of a review of the developmental AI talk that we gave at NeuroMatch, and so I had some additional thoughts on that. And I'm not going to go into the slides right now, but I do have a sort of the final slide, or I think it was maybe second to the final slide, where we had the comparison between epigenetic landscapes and gradient descent. I'm going to bring that up in a bit, and I want people can think about it. They don't have to give like insightful answers right now, but I might go over that once more. Other than that, we have we have the talks on YouTube, and then I'll show an example of how we're collating the references a little bit better, or organizing them a little bit better. So this is the task board. So for Danielle, for Gabrielle, who's just joined us, this is the task board that we use for organizing things in the meetings. And we have a GitHub group, so we use GitHub a lot to organize these meetings. And we do, we do some coding, and we also do some just kind of like working with text in GitHub. And so this is our GitHub organization here. This has a lot of our different projects. So this is the meeting here, Saturday morning NeuroSim. And then these are some of the projects that people are doing. One of them is Jesse's project, a survey of cognitive models. But there are other projects as well. And so we'll be referring to this GitHub site, probably weekly, to try to give people, okay, so this is the thing I'm talking about here. So we have a lot of the different meetings archived. So I've gone back to October 3rd so far to archive each weekly meeting. So these directories here, they're labeled with dates. If you miss a meeting, you can go back to earlier meetings and, click on that directory. Jesse, why don't you click on, November 21. No, actually, that's a good place to be. Go to meeting notes. Okay. So this is the meeting recording here. This is a Twitter thread that I prepare after the meeting, which includes some readings and other things that we follow up on some of the things in the meeting. This is the presentation that I gave. This is just kind of a overview of some of the thoughts. Yeah, so these are the slides here. So just recapping the talk, adding new things. So yeah, we just kind of walked through these different topics. And that's not, it wasn't a highly organized talk, it was just some thoughts about it. And then here's some supplemental notes down here, which are some links to things that I didn't put in the Twitter threads. So we talked about the dual inheritance model. We talked about affordance as an evolution. And so if people want to add to this, they can issue a pull request, or you can put something in Slack and just say I want to contribute this to the meeting notes, and we can get it up there. And so then this will be a reference for everything that you missed out on, but it'll also help people who went to the meeting to understand what went on and digest it a little bit, because we do cover a lot of things in the meetings, and we do a lot of things. We have this arc of things that we do over time, and we kind of forget about them, I think. And that's true of most research, where you forget about 80% of what you're doing. You do it and then you put it away and you forget about it. And that's not necessarily productive. It's just kind of something that's we can help overcome. Let's just put it that way. So that's actually the picture I wanted to talk about, but we'll talk about it later.
This one?
Down.
Oh, this one, yeah.
Yeah, that one. So this is the one, the landscape versus gradient descent. This is the last, I think the second to last figure in that talk. And I just wanted to point out to people, and if you don't know what these are, I'll explain what they are. So on the left, we have something called an epigenetic landscape. And this is a tool that they've used in developmental biology, actually, to describe something that is undergoing development. So they don't use this in developmental psychology, but they do use it in developmental biology. And in this case, we have a cell, like a stem cell, that's differentiating into different cell types. And they follow these paths, and they're called channels or like valleys. And the idea is this ball, which is the stem cell, it rolls down this hill, and it finds the path of least resistance. So it goes down these channels. And these channels represent different developmental programs or different developmental states that are most likely to happen in development. And then you see that you can go from a single stem cell that's undifferentiated to a number of differentiated cell states. So you see at the bottom you have these wells where you have different balls, which are different variations of this original stem cell. And, they're different states, like it could be bone cell or muscle cell or brain cell or whatever. And so they all follow this path, which is this path of differentiation, and they go down into these channels. And in the literature, they call this canalization, which is where development tends to take a certain set of pathways. There's, a lot of developmental plasticity, but as we said last week, a lot of that plasticity is lethal to the organism. So you could have you could have an organism that has 5 eyes in development for some reason, but it doesn't necessarily survive to become, for the egg to hatch or the, So this is, this is the way development proceeds, and this is the way people have thought about epigenetic landscapes largely as a sort of a metaphor, but there are people who've worked out the mathematics of these. So they've done this largely for like stem cells, and so they've worked out like how a stem cell can go from a stem cell to something differentiated, and what that looks like. Now, when you go and get into the mathematics of it, you end up with an interesting parallel with what they call gradient descent models. And this is something that we see in machine learning and deep learning. And this is it's basically an energy landscape. So the idea is that if you're trying to solve a problem in a domain, you have this landscape of possible outcomes. And those possible outcomes or answers are all arrayed on this landscape. And so there's some answers that minimize energy, so they exist down here. There's some answers that don't minimize energy, and they sit up here, or they sit at some local minimum. And so there's a whole language to this and a whole mathematics to this. So people talk about these. If you read machine learning literature, you know that they talk about these models all the time, and this is sort of the benchmark for performance on an algorithm. Now, the reason I bring this comparison up is because in development, we have these landscapes. So we basically say, okay, we're going from the top, and we're trying to minimize our developmental potential, or we're trying to minimize, the types of changes we can make in an organism, but we want to get some developmental diversity so we can get a bunch of different cell types, or we want to get phenotypic variants or something. And in this case, we're trying to minimize energy. So when we were talking about our developmental algorithms and our developmental AI stuff, we have this sort of comparison to make. We haven't made it before. We didn't make it in the paper that we wrote because it was, it's a bit hard to make that connection very quickly. But I wanted people to think about this comparison. And I don't really know. I mean, some of you are familiar with, energy minimization or gradient minimization, and some aren't. I'm somewhat familiar, but I don't know that, I'm not like an expert at it by any means. So just to let people know that that's kind of the thing we were thinking about last week in terms of this kind of comparison between the two types of construct. Interestingly, they all sort of tie into, if anyone's familiar with Hamiltonians and energy minimization in statistical physics, but that's really where gradient descent comes from. And that's where a lot of the landscape thinking comes from as well. If you think about fitness landscapes, which are a little bit different, but they operate in the same principles as epigenetic landscapes, that comes from that line of thinking. I think is the Hamiltonian, that sort of model. So there are a lot of connections to be made there, but it's something we have to think about, in this developmental AI area if we want to pursue that. We did get our reviews from the paperback, and one of the reviews was that we didn't make an explicit enough connection to algorithmic thinking, conventional algorithmic thinking. So that's why I bring it up. But I mean, that's one of the things I wanted to point out from last week to follow up.
Yeah, I think there's a lot of background noise somewhere. Those little, yeah. But I think that was good for that. And also, just to kind of mention it, it's not necessarily required reading that anybody comes and looks at all the past stuff. We a lot of this discussion about how to use what is on GitHub and Twitter, what we're doing. And rather do really good about making these Twitter threads that are sort of easy recaps of some stuff, because we've had a lot of discussions of note-taking, and Rashad, who's not here right now, and myself and Bradly have been, so many times we have these different thoughts and trains of thoughts that are sort of, how do we keep track of them? So these are some new efforts if you can track of them, and I think it's really good. And even just like how easy it was, like it wasn't totally planned that we were going to talk about things, and show off what we did this way. But at the same time, it kind of was because we're kind of baking into, if we want to talk about something from the last meeting, we can just go a few clicks and there it is. So I think that's a really cool thing to be able to do, and that way it keeps this conversation a little bit fresher and a little more accessible to different things. So that was a good overview of what happened last week. Let's see. So that's
Are you there, Jesse?
turned.
Okay. Oh, is your Wi-Fi?
Yeah, I don't quite know. Can you hear me okay now?
Yeah. I couldn't hear you for a minute there, but
I cut out.
Okay.
I don't know the last thing you guys heard.
Oh, we're just going over the board a bit. Yeah, I don't know.
I was basically saying, so it's good to go over that stuff. I don't really have any major updates on this sheet, although just to mention it here, like here are some new things that I didn't set the date for. I think this is happening quite soon. The Montreal AI and Neuroscience Conference. What's this one here? But if there's any new events to note, we have a sheet to kind of collect events that are upcoming, like OPAM, alternatives back propagation, obviously NeuroSim. Just to kind of keep track of things that are upcoming, and some different details we want to put them in about other stuff. I haven't really added anything too much outside of these new things here. But I've been really busy with my own graduate school life, and applying to graduate school specifically. So I don't have a lot left there. But I know there was some talk about integrating different aspects of this into, I don't know, if we wanted to have a way to collect links or other ways to just get things easily into a spreadsheet. So I don't know if there's any new thoughts about that, but I'll kind of leave that there for the time being otherwise.
The only thing I can think of is like a form. People can submit things. That might actually work.
Oh yeah, that's a good idea.
Because you can do a Google form and it'll go right into a spreadsheet, as input.
That would be best for other people to do it,
yeah. And then it would just be like a matter of putting it into that spreadsheet, just as things are updated. Because I don't know if we'll get a lot of submissions, but it'll be something that people can put everything in one place and then.
Yeah, definitely. Okay. So I saw also in our active project stuff here, I saw there was some new stuff for the Philosopher's Web Cafe talk. I don't know if you wanted to talk about that. I don't know. There are a few other things to talk about. I think Anson spoke a little bit about his. Anson gave an update on his project. So I'm just going to make a note of this for myself here. But if there's anything that people had planned to talk about today otherwise, let me know. but I know we could talk about the web cafe talk, or anything about the cyber cafe talk. I guess that's answering stuff right there. Yeah, anything that you wanted to say about those two things, Bradley?
Well, I have the Philosopher's Web Cafe. I've been working on the presentation, so if we have time, I might go over some of the slides that I have now and get people a little interested in it. Maybe but I don't know if you wanted to give a presentation, or you had a presentation on your stuff on surveying cognitive models.
Yeah, that I can do that. That's kind of a that's like a not too long, but it's a pretty, I don't know, 10-15 minute presentation.
Yeah.
I don't know if we should do that now.
Yeah, just let's see. Let's finish this up a little bit. The Cyber Cafe Scientific talk that was submitted, and so that is ready. I mean, I think it's in Slack. If it's not in Slack, if you could put that in Slack, Jesse. Yeah. But other than that,
what?
Yeah.
Random?
Oh, those are slides from the.
Is this the same thing?
No, it's different.
Or did you mean? Okay.
Yeah.
All right.
But yeah, so we haven't gotten that accepted yet. So when we get that accepted, we'll talk more about that. But that's in the process of being evaluated, I guess. But we do have a plan for it, and if it doesn't get accepted there, we can still do it. We can submit it somewhere else, or try to, do it on our own. It's just basically an hour-long talk online. And it's just about this lab and how we've sort of enabled distributed collaboration. And so it'll be, not really, I mean, it is about the science that we do, but it's sort of a meta-science take on things. So that's available. And again, like if anyone wants to participate in any of this, you can express your interest and you can be a part of it. It's not like there's no barrier to entry here. We're trying to keep things pretty flat in that way. So Jesse, why don't you move on to your talk? Oh, that's the sessionize. Yeah, that's for the cyber cafe thing. Are you muted, Jesse, or?
Sorry, apparently I muted myself. I was saying, sorry, the link didn't work out. Is there anything you want to talk about, anything to discuss before I go into that presentation that I had planned?
Does anyone have any questions at this point before we move on?
Yeah, or any questions about like the whole GitHub? Obviously, is sort of we're kind of commandeering it as an open source project management that's very transparent and open in this way. And you can add issues to this board too. Any questions are welcome. Okay. So, I don't want to do that. If everybody's ready, I'll start with this. I guess so. Okay. So this project, Survey Cog Model is a really not easy to pronounce way of referring to a project. It's the goal of it sort of is a survey of computational model recognition. And I'm calling it Survey Cog Model right now. It doesn't flow, but I'm kind of keeping it that way for the time being. just because I wanted to. It's actually been ongoing for a while. It's just I wanted to redo some of the proposal and reformalize or break some of it down into more concrete parts. And so I made this fancy logo, and for those of you guys who haven't been around the last couple of weeks, I've been doing a lot of updates on. There's a website that's kind of associated with the Cognition Futures, which is this research team that I'm leading or developing. People can join that or be involved however they want. And this is kind of I finished this survey a week or two ago, or excuse me, I finished this presentation a week or two ago. So there hasn't been a whole lot of updates since then, because I'm mostly in like graduate school application period. But I kind of wanted to present this just to get in the habit of presenting regular updates about this specific project and show what's going on, how I'm breaking it down, where to go forward with it. So yeah, just to kind of go what I'm going to do in this quick talk. I want to go over Frontier Map, which is kind of the godfather, granddaddy, macro umbrella project of it. Some specific things that are going on inside this talk. Some of the driving questions and like where they came from. I may not review the proposal here. I might just show it quickly and explain what Part 0 is, which is basically Part 0 is kind of setting it up, basically. And I might go over these components, annotated bibliography, literature review, the methods, and some of the deliverables I wanted to do. So Frontier Map, an umbrella corporation project. Actually, that's not quite right. Sorry. It's actually not part of umbrella. Anyway, an umbrella project. So some of the background is that this came from, this actually was an idea I had almost a year ago, and it stemmed into, it was sort of presented in an official way as part of this epistemological directories for research, development, and education. Obviously part of our lab stuff. And this was at CSV conference version 5 2020, which is of course virtual like everything else was this year. And Bradly kind of spearheaded this project, and epistemological directors are sort of, I'll let Bradly say anything about that he wants to, but in general, it has to do with trying to keep track of many different, especially novel or interdisciplinary veins of inquiry, and how do we kind of create some organization and ways to teach about them, understand them. Like, these are both slides from that, and one idea is like the theoretical minimum about very, very, very essential bits of information so you can get to a place and to understand the field in its context of other things and where it's going and so on and so forth. There you might have heard of knowledge maps, and this is all from that presentation. You might have heard of knowledge maps, which kind of break things down into timelines or trajectories of development, or epistemological maps, which kind of do the same thing and discuss what we know, what we don't know, and try to bring some categorization to it. And then frontier maps for me was a specific take on how do we go from when I talk about the frontier, kind of what I was thinking of originally, and kind of at the time of this presentation, was a really broad landscape of, all right, well, what is cognitive science in a very broad sense of like, okay, well, there's neuroscience, there's cognitive science, which is inherently comprised of 6 other different disciplines. And there's a huge debate, which is part of something I'm looking at in another project of mine. Like, there's a huge debate of like, what happened to cognitive science? Is cognitive science now its own thing? Is it really just, part of psychology now? And where did it go? And where's in the trajectories of development of all those things? And what's sort of on the horizon of those many different fields of study about the brain and the mind, and how it's actualized either in robotics or modeling cognitive systems or neuroscience or the philosophy behind it too. And so kind of like just to kind of go deeper into the inspiration of the Frontier Map project, a vast unstructured set of arenas, and potentially foci in those arenas. Like, how do you make sense of that? That's one of my big things. Is like, how do I start even figuring out exactly what it is that I want to study? And there's this whole sea of these leading conferences that are sort of founded in very specific disciplines like neural information processing systems. Okay, Association for Advancement of Artificial Intelligence, Society for Neuroscience, International Conference on Learning Representation. You have these topical institutions bringing people together, and those are sort of the cutting edge. But like, the more I went, like, there was so much context that even in just like straight up computer science, it's like, well, what am I missing? Because there's references being made, and granted, I don't have a PhD in computer science yet. I don't even have. I have a bachelor's in a related field, but especially in those areas or anything related to quote unquote cognitive science or whatever, or this sort of what I'm calling the frontier of these brain and mind related things. There's a lot of context, and how do we really have? There's references that I really understand. So how do you really start getting a hold of that? You kind of dive in, and then you try to create connections and gain the context. And that's a messy part of learning any field. But I feel like particularly for this frontier that I'm talking about, there could be a little bit more. I see a need for some structure, or at least learning materials in that sense. And like I mentioned, there are a lot of cycles and throwbacks, like AI winters, and things keep getting references from different points, and the technology catches up to do certain things and stuff along. But it's like there's this context that you don't really have. So this is all kind of a part of that. And then like survey cog model is what I wanted to do is kind of create what takes us to this project, which was kind of about creating this catalog of how people have been thinking about models of cognition in the computational sense. So like really simplifying some of my questions in this project for survey cog model. Fundamentally, what are some? How do I break things down and map technical computational evolution of models of cognition? Okay, why? And trying to figure out what's my motivation for wanting to do this. Like, I want to basically understand what has been tried and what hasn't, what the paradigms are, and what things were influencing those models of cognition. And so, as far as how, what questions can we center this investigation around? What should I highlight and pay attention to when looking at this history of things? What's the signal and the noise? Kind of a thing. And so refining those questions a little bit more into specific things. What are we trying to identify? How do computational modeling of cognitive processes evolve? What languages or software were available that enabled or limited those models? What hardware enabled or limited those models? What paradigms and theories supported those models? And the second major driving question set is, what are existing taxonomies for discussing these models or these sets of models? How do we sort of categorize or differentiate them? What are they lacking? What could be improved? And then third, which I'll kind of specify this one a bit more later because it's quite broad. What developments in other fields influence cognitive model? Like, that's a giant. That's a whole thing in and of itself. But neuroscience, quote unquote, artificial intelligence. What we call artificial intelligence now is not necessarily the same thing as what it has been, and that what is machine learning, deep learning now, cognitive science, philosophy, linguistics, engineering, robotics, anthropology, and so on. So the project survey cog model is mostly about 1 and 2, but 3 is like absolutely vital to my personal interest too. But for trying to if my goal is trying to scale down and create some very tangible, concrete chunks of stuff to focus on, I might not necessarily incorporate 3 heavily into the main component of what I'm doing here. But that's like, you know, the cognition study group that I've been helping get off the ground too. It is really all about number 3 in a lot of ways. So just mentioning it that way. Some other questions to bring up here, and these aren't things that I have set totally, but like, what is a model of cognition? What is a computational model of cognition? And how has this changed over time? You know, it's not something that's been set in stone. Or what has changed since capabilities and technical capabilities have been able to change as well. Other questions? I think that's, yeah. I would open this up just for a moment right now. If there's any immediate questions people have that I could quickly try to address or say, we'll talk about this in a couple seconds. And if not, that's fine too. Okay. Let's see here. Whoops, I think I just... Sorry. All right. Can people still see my screen okay?
Yes.
Okay. Okay, because I hit something here. Formative, so it's like some formative concepts that I really would like to kind of bring up in parts of what I'm thinking about. The beta lesson, I think, is really interesting. I won't go into that here, but that's come up quite a bit this last year. I had the fortune of virtually semi-meeting Richard Sutton at the iClear 2020 virtual conference, and I really appreciate sort of the talk that he had, and also just he spent a lot of time with, you know, a bunch of young people trying to find a way in the field of all this stuff, and that was really, I really appreciate that experience and the talk that we've been, you know, in one sense you can look at his lesson as how do you not get bogged down in applying some of the specific things and looking at the big picture of learning, looking at the big picture of comprehension, understanding. And I think that's, and staying true to that quest as opposed to being distracted. So that's something I'll return to. Embodiment and 4Es, those are kind of like, you know, big part of what we call what's hot and how people are talking about cognitive science now. But I mean, embodiment is kind of a special. I'm glad that it's kind of become a point of talk about here in the lab too. The cognitive revolution, and broadly speaking, is sort of like what happened in the 50s when people got really excited about, they kind of started creating this, ooh, what is cognitive science? And it, oh, well, now the brain is like a computer, and we have computers, so we can start, you know, creating these very specific things that are very computational. So that's sort of, you know, very historically a big period and effort, and a lot of question now is like, what happened to cognitive science, and also sort of what happened, what's left after the quote-unquote cognitive revolution. Symbolic versus connectionist, the huge ongoing debate in computer science and what we call artificial intelligence, hybrid models and all that stuff. Winner and summers of AI, we talked about this in the lab a few times. And other notable features that I might want to incorporate in as I look at stuff in this project and try to categorize and look at these models over time. Models of development, obviously that's hot for what we're talking about in the lab too. Allostatic regulation, again, very related to Anson's interest and my interest and our developmental work there too. Cybernetics, there's so many throwbacks to classical cybernetics and every regulator theorem. And these other things. So I kind of mentioned that quickly here. The free energy principle. I was going to mention earlier, like there was a person had a paper on gradient descent and active inference that I very poorly reviewed months ago, and you know, just kind of pointing out there's a lot of overlaps here. And I'm not saying I'm going to go into all these things in my project, but just kind of mentioning, hey, these are specific, you know, keywords I may create certain discussions around as I go through things. Annotated bibliography and literature review, some major resources that I have, you know, and I'm very open to people having suggestions or ideas about this. Definitely Margaret Bowden's Mind and Machine is kind of like been recommended as sort of the ultimate compendium of a lot of cognitive science stuff up until, like, you know, historically until the middle of the first decade of this century, like 2005, 2007, it was published. So it's kind of like, that's kind of it. And I kind of mentioned this specifically because I feel like at that time, you know, reading a little bit of the book, Margaret really commented like, yeah, you can have a book that's like here's the state of the art, you know, in the 70s and maybe in the 80s. And as you got to the 90s and then in the 2000s, like, there really isn't a comprehensive book anymore. Like, there's so much diversity and so much stuff going on that it's not just a matter of, oh, well, you know, this professor at MIT is all you need to know about this. And then you have, you know, Rafael Nunez, and you have, you know, it's not really as simple as it's very diverse now. And again, this kind of lends back into why do we need some concept of a frontier map? Why do we need some concept of these kind of projects? Because about the time that Margaret books end, it's like there's just an explosion. This is kind of obviously pre-deep learning taking off too. So it's sort of like, I'm not going to break things necessarily down into these categories of time, like pre-2005 and then 2010s and the next one necessarily, but just to kind of have it, just to kind of say, here's sort of what I'm looking at. I think it's kind of, you know, I'll be discussing how I break things down and different groupings and stuff next, but just to kind of mention some major resources. I mentioned Bowden's book, I mentioned Rafael Nunez, and his, you know, What Happened to Cognitive Science, to me, is, at least like for my interest, is sort of like a landmark paper, and there's many responses to it, and challenges put out from that paper, really critiquing the whole field, and Rafael is like a big name in the field, and he's done a lot of work in it, and so he was sort of, you know, offering a critique of the field, and, you know, and then there's responses to that, and then the advent of deep learning and big data. That's kind of why there's a very different era after, you know, there are many different eras, but there's a very particular cut in my mind around that time period. And then you look at it like looking at some of the future stuff ahead. The Next Decade in AI by Gary Marcus he's kind of a catalog of some models of hybrid models that, you know, where are things going for cognitive science that are sort of theoretical and you know, some may be more out there than others, but kind of looking ahead. Anybody has any suggestions, I'm always interested in that. Please reach out to me on Twitter or otherwise. You know, I'm open to those sorts of things. And always looking to refine that. I have an ongoing bibliography, a different like the project has its own GitHub page and its own sort of repos of collections of materials. So I'm always looking to add to that. Just to go over the bibliography really quickly, some of the methods, things I want to include: source material. I like to have a discussion about the taxonomy or include them in my own taxonomy. Look at the computational elements, language, hardware, coding examples as much as possible. I want to have some coding examples in notebooks. That may not always be practical, but I want there to be a sense of, okay, here's a chunk of the code. What's going on in the code? How do I, what do I do? Very nuts and bolts. It may not be fancy. I've done this a little bit. Like, I've had some very simple models, like really early stuff that's just like not really exciting or fun or sexy to look at, but just kind of having stuff there to see. It's kind of what I want to hope for. I don't know how that's going to work out, but that's the aim. And then I would like to have some specific reports and classifications after I have these sort of primary sources, and creating some reports about them into, like, you know, broader topical categories. And this is kind of why, like, getting in the habit of presenting here, creating some blog posts or synthetic daisies, which is a lab blog. Just these ongoing ways of categorizing the material that I'm trying to sort of churn up. And so specific deliverables, yes, the bibliography, which I kind of mentioned, highlights from specific eras, and figuring out how I want to group things. I'm probably going to do chronologically for the time being, but I think there'd be better thematic ways of categorizing the models of cognition as well. And again, code notebooks with materials as possible. and potentially looking at creating some new taxonomies or ways of categorizing stuff. Obviously I don't know all the existing ones right now, but I'm getting more and more understanding, and we'll see if they create anything from that. And those kind of all fit into questions 1 and 2, the driving questions that I mentioned before. And for the reach goals and future work, separated to question 3, which I said may not be directly part of the project. Narrative tie-ins and bridging to develop some adjacent fields. Like if I could just have infinite time and resources and whatever, I would love to create like a full-fledged, really make this like a really integrative map of, hey, well here's a cognitive model, but it's also adjacent to, you know, this debate in cognitive science or this development in neuroscience, where people have, you know, saw this and that affected that, and then, you know, having a big influence map would be great. But I don't know, that's definitely in the reach goal area, and for what I'm trying to do here. Any questions or suggestions? Just thoughts that are on my mind about this. I'm probably going to pick a general starting point of the 40s, or between the 40s and 60s, and maybe go by decade at that point. I would like to include, obviously there's been stuff, you know, there's been things thought of before the 40s, but you know, figure out how to do that will be its own thing. I think for the next step of this project, it will probably just be one of those decades and go from there. I think looking at, I don't quite know if I meant developmental here, like as in developmental AI and developmental psychology, or other things, but yeah, I don't quite know what that means now. Oops. And identifying source materials, like getting to the original paper as much as possible, or the original places the model was talked about or developed. Annotate and document, collect taxonomies, and again, suggestions or comments are welcome for that. Let me see. And I want to say thank you for our team. I guess this is from another project, actually, sorry. Thank you to our team, the Cognition Futures team, which features from left to right, Bradly Alicea, Director of PI, and who I'm taking great liberties at in this presentation and making a lot of inside jokes to myself, and I appreciate Bradly giving me the space to do that and mostly work on this project. Like he's been very supportive of this, so this is kind of me starting to have more big boy presentations about it, so I appreciate that. I had to throw in someone here for this image. It's actually Margaret Bowden. You're probably going to be drawing from her book a lot. That's Anson Lim, with all heavily distorted pictures. So thanks, Anson, for your endless conversations about these topics and what you're doing as part of this. I had to throw in Norbert Wiener because I'm a little bit of a fanboy of his work in cybernetics and his take on ethics a little bit. And then me with a weird picture there. So yes, that's the talk for the time being. And if there's anything people want to say, you can reach out to me at any point. So.
Well, that was good. Thank you. Yeah, it's very good. Very good start on this. Are there any questions generally about what he's shown here? Any suggestions?
Yeah, I think there's a lot of stuff. What I wanted to do with this project and this overview is to not just create some very broken down boxes into things. So, in many ways, there's been strands of development on this project for a while, but wanted to make them concrete and say, here's where I am. Oh, I think I even have, where did it go? I have a specific project set about this too. Like this project will be an actual, you know, some specific things here and cross them off, like I just presented on this stuff. So that'll be done. I want to have a very limited number of issues and deliverable things here, and then move them to completion and be done, and not add them and have it be done. So this is one of the project boards that's actually a specific, concrete, limited, finite project board. But anybody wants to talk about that, feel free to talk to we can talk about that more later. I took a good chunk of time here, so thank you for your attention and patience with that.
Yeah. Ash, do you have anything to? Do you have a question, or I see you have your camera on now?
Nope, I didn't have any specific questions. It just came up.
Okay. But Gabrielle, do you have any questions or?
Not at this point in time, no.
Okay. Anson?
I don't have a question about the commons. I think it'd be interesting to look into different taxonomy or spatial dimension-based ways of relaying different disciplines. But I don't know anything about those methods, but I think it'd be interesting to look. It seems like something interesting to look into.
Yeah, there's like definitely some meta organizational stuff, and it's like really tied. The taxonomy stuff really fits in with a lot of the. For those who don't really know in the lab, there's a major research thrust of like that's why it's up here, epistemological directories, and this is something that obviously Bradly's been working on for much before I joined the lab. And just kind of ways to navigate this space. So there's a lot of overlap between those sorts of things, and trying to do. You could do a whole like comparative analysis of taxonomies for sure, and I think I'm at a place where it's going to be a matter of trying to categorize some of the top stuff and go like, because I could spend a really long time on that, and I would like that, but at the same time it's sort of like, how much time do I want to spend on that versus like, here's some existing taxonomies and here's kind of what I'm creating myself, and kind of doing a very that's going to be one of the hardest parts. I think it's going to be, what do I exclude, because it'll be fun, and knowing how I am, it'll be fun to go and deep dive into all these different details of different ways. Like, oh, here's the developmental cognitive neuroscience approach. Here's the neuroscience way of talking about this, and merging different fields of biology and cognitive science or psychology or computer science. Like, they all have their own nuances and stuff too. So that'll be an interesting challenge to do, but one I'm definitely interested in trying to manage, because it's sort of like you kind of have to draw your lines, especially for stuff like this. Any kind of the mapping stuff seems to entail that. So definitely, yes.
I had a question. Well, I had a comment on the. Well, I think it's good overall. I just had some comments about the literature review part, and this is going to be a challenge. Yeah, I think. Yeah, there. So the question is where to start, and pre-2000s I think is a little bit like. I mean, I don't know how granular you want to make this, but there was a lot happening pre-2000s. So there's
that's like. Absolutely.
Yeah. So, I mean, one of the things I was thinking of Andy Clark, maybe having a section on him, because he's written a lot about like mind and machine from different perspectives. It's more philosophical, but it's part of the cognitive science milieu. Maybe people like Marvin Minsky or some of the early AI people, and then there are also cognitive psychology people, who you can include in there as well. And I think that's a good, good sort of, as opposed to just, people who are familiar to the AI audience, also people who've done like work on different areas of cognition, like attention and decision making and memory, learning and memory. And I mean, I can help you with some of that. There are probably other suggestions that people will have. But I think, and then the other thing, of course, is what's sort of the outer bound of this literature review? Because when you write a literature review, you think, okay, what do I need to include to make this like really, exhaustive? But at the same time, I don't want to go too far afield because it's, it seems like it's pretty, you could go forever, but also it just kind of muddles the message. And so I think, like, in this case, you have some people and that's the thing about cognitive science, is it's not just one field. It's kind of like they call themselves cognitive scientists, but really, I mean, there isn't that, except for some major people in the field, it's really hard to feel out the boundaries of it.
Right.
So it's like sometimes it's philosophy, sometimes it's cognitive psychology, sometimes it's in, computer science, but they're all kind of going in the same direction. So I would think, I would kind of establish that as well. Like, what is my scope of this for people who may be coming from maybe nothing in terms of previous knowledge? How do I think about this field?
Yeah, definitely. And I think that's sort of the, if this sort of part 0 was mostly sort of in-house, almost like an administrative review of what I'm trying to do, I think that is sort of the foundation for a user of the project, is that. And that's the next step, and that's like part of every step. I think each project chunk will be kind of an addition or review of what that is. So I agree totally. And also, like, just to mention, the stuff on this screen is absolutely not exhaustive. Like, I'm not going to use, free books or whatever. But absolutely those figures. As I kind of just mentioned, I don't know, and maybe it's a bit unclear, but I will definitely be using those names that mentioned and more. And also, like, just to kind of say, that is one of the things, like, in cognitive science was sort of this during the cognitive revolution, with this attempt at bringing, like, 5 or 6 fields together, and one of the questions in what happened to cognitive science has to do with, where was this big unified, we're supposed to have this unified effort and collection of moving towards a coherent scientific, enterprise for mind cognition studies, and sort of where did that actually go and where does that not go? So that will, in one sense, what I'm aiming to do is sort of impossible. So absolutely, like, a major part of the project is creating some demarcations and drawing some boundaries to make it possible and at least coherent. So yeah, it's definitely, there will be probably quite a few revisions about what those are as I go, but I want to start moving, and this is an effort in the direction of making it more demarcated. So yes, definitely.
Yeah, definitely the revisions. I mean, we can do open revisions. I mean, there's the thing about a literature reviews. It doesn't have to be, like, complete. We can have, like, where we have, like, the major demarcations, and then, some references, and then people will continually add to the references, and it'll give you, like, it'll be really a living document, in the sense that, it's always kind of, people are adding in references, or you're adding in references, and as you learn more, it's, you get maybe like a new version of it that you want to make people aware of. You might, release it and say, this is a new version, we've changed some things. It's a lot different than people have done literature reviews in the past, because literature reviews, people will write them, and then they'll tend to get moldy. They'll become irrelevant, because they're sort of a review of a certain point in time, and then you publish it, say, in a paper book and then in 20 years later, it's not really that relevant anymore. So I think cognitive science is probably fast moving enough where we could have like a living sort of literature review, and that would be an excellent addition to the field.
Yeah, and I probably didn't mention this directly in the presentation, but one of like a deliverable that I would really like to have at the end of this would be sort of not actually Devo Zoo inspired, but an accessible catalog of, I don't know how it would really be accessible in the sense of, I don't know, with infinite time and funding and resources and manpower and hours. Yeah, I'd love to have an accessible catalog or website or web, even a Wikipedia kind of setup of just some of the models, like here's your models of attention. Here's your really robust models of of cognition or whatever you want to say, and just be able to click to them and say, oh well, here's and just have these little cards come up that say the components of them. But that would be a really nice sort of output deliverable user, almost like a user interface kind of a thing. Just so people could see, oh, here's an example of this whatever. And ideally having this lineage of what went into that. But I think part of why I didn't say that specifically is because it's such a, wouldn't that be nice? And I don't know if that's going to happen at any time in the near future, but that's some thoughts I had about that.
Oh, yeah.
Yeah. Yeah.
Okay.
So thank you for those thoughts, and any of the thoughts today in Slack or anyone else.
Yeah, so if we have thoughts about this, we can put them in Slack, or the next week we can revisit them. So let's keep that in mind over the course of the next week or so. And then, yeah. So I'm going to spend maybe another 15 minutes here on some things. If you have to leave, that's fine, but I'm going to try to go over maybe one or two papers really quickly. Jesse, okay, thank you. I was going to share my screen. That's not the right one. So, okay. Can you see, let me see. Can you see my screen? Okay. So this is, yeah, I have a lot of things in here. Let's see, where do I want to go first? Well, I did want to talk a little bit about this before I move on to the papers. So this is the presentation I've been working on for the Philosopher's Web Cafe talk that I'm going to be giving on December 11th. And I'll give more information about that as we get a link and things like that. But so this is observer-dependent models, and I gave a talk on this in one of our past meetings. This is kind of a thing where I'm using these agents throughout the talk to illustrate things. So it's like this is a play on Pac-Man ghosts, but so there are 4 different agents I'm using to illustrate these ideas. And so this kind of goes through this idea of an observer, and we start off at quantum physics because that's a common thing that people talk about when they talk about the observer. There's a specific interpretation of quantum theory that stresses the observer, but then we can also move into the every good regulator theorem, and in cybernetics, where they also talk about observers. And so I think there's a reference I found on white boxes and black boxes, which is from a cyberneticist I had never heard of, Glanville. So I looked into that a little bit. I mentioned that. And then we kind of go into what it is to be an observer, putting a body on the observer, and then get into a little bit on collective intelligence. I talk about Gibsonian information, which is something that we've been talking about in the group here. We're kind of formulating this idea of Gibsonian information, and I'm going to develop it a little bit more for this talk. So I'm developing a little bit more of the mathematical framework for it. So there's coherent movement, there's contingent action, there's disjoint distribution of information. Then I move on to these genotype to phenotype mapping agents. I move on to these morphogenetic agents, which, this is all something that'll be covered in the talk. And then these viewpoint networks, which I talked about in several weeks ago in the original presentation to the group. So this is based on this presentation I gave to the group here. And I'm still working on it. So I have another couple, maybe a week and a half to finish this off, but this will be December 11th. I'll give the date and the link when we get it. So let's see. First paper I want to talk about here. Okay, this one. Gaussian process linking functions for mind, brain, and behavior. This is a paper I found this week. It was actually pretty interesting. They talk about the link between mind, brain, and behavior as mystified philosophers and scientists for millennia. Recent progress has been made by forming statistical associations between manifest variables of the brain. So they're measuring the brain using different neuroimaging techniques, EEG and fMRI, and there are others that people use. Basically, they're getting a snapshot of what's going on in the brain. It's either a direct measurement of neural activity or an indirect one, like in fMRI, where you're measuring blood flow, and it tells you something about brain activity. And so then they're also manifest variables of behavior. So we can do things like measure response times and accuracy. And so these are things that you see in cognitive psychology experiments. And these also tell us about what the brain's doing. So within this framework, one can make inferences about the mind in a statistically principled way, such that complex patterns of brain behavior associations, and that's linking these measurements of the brain with measurements of the behavior, drive the inference procedure. So in other words, if you take your measurement of the brain at a certain point in time, the state of the brain, and then what the behavior is doing, you can make connections. But it relies on usually some sort of statistical model of what's going on in the brain. So people have used things like internal models to say for movement. People have used internal models of the cerebellum and other brain regions. There are statistical models that basically try to predict, movement given a certain brain state. And those have been actually used quite effectively in brain-machine interface technologies. But this is all, it's a statistical model, and so we keep that in mind. However, previous approaches were limited in the flexibility of linking function, which is proved prohibitive for understanding the complex dynamics exhibited by the brain. In this article, we propose a data-driven, non-parametric approach that allows complex linking functions to emerge from fitting hierarchical latent representation of mind to multivariate multimodal data. Furthermore, to enforce biological plausibility, we impose both spatial and temporal structure so that the types of realizable systems dynamics are constrained. And so they talk this. So it's a lot of statistical stuff that they're doing here, and they do a simulation study, and they apply it to experimental data. So they're able to fit their model to neuroimaging data and behavioral data for a continuous motion tracking task. And so the model accurately recovers both neural and behavioral data and reveals interesting latent cognitive dynamics. So let's see if there are any figures in here. So this is one example here of the framework. So you have a stimulus, you have brain activity, you have behavior, which is manipulating a joystick, and then you have the structure of the brain. So all those things go into these are all sort of controlled by a latent process. So the stimulus and the structure go into this latent process, and out of this latent process is generated both behavior and these brain states. And so this is these are examples of what these different outputs look like. So this is an EEG trace, this is fMRI signal, a bold signal, and this is behavior. And these are all just sort of over the same time interval. So, there are things that are going on in the brain that are producing these things. And so how do you integrate these all together? And so they're actually using something called a generative model of brain function. So, so they talk about Gaussian processes as a linking function. And if you're not familiar with Gaussian processes, they're basically like, if you're familiar with the bell curve, that's what a Gaussian process is. It's a process that follows its sort of normal distribution. And so you generate a bunch of data that conform to this Gaussian process. So in other words, whatever this process is, it's generating a bunch of values, and those values conform to a mean with a standard deviation. And that's, that basically, a lot of machine learning approaches rely on this sort of Gaussian process, where there's this normal distribution of events from a mean. So there's a mean, and then there's some standard deviation around it, and it's actually, there are outliers and everything. It doesn't assume that, it doesn't really deal too much with things like rare events or other types of outlier events. So it's a good model, like a heuristic model, which means that it's a good way to sort of describe a general accounting of what's going on. But it's not always the case that behavior and brain activity conform to this Gaussian process. So they use a Gaussian process here to characterize this internal model. And so this is another figure. And there's a lot of math in this paper, but I'm not going to go through any of it really. And then these are their simulation results. So they're able to characterize spatial, temporal, and spatiotemporal estimates, and they get. So these are their results. I'm not going to interpret the results either, but this is. In these kind of overviews, I just want to give people a little bit of an overview of what these papers are about, and then you could read them on your own if you want. So that's, I think that's probably enough on that paper. I'll give you the link to this directory, and if you need access to it, I can give you access. Let me put the link in the chat. All right. So that's that paper. That was Gaussian Processes Linking Functions for Mind, Brain, and Behavior. Let's see. Another paper is this one, Beyond Connectionism. So this is commentary on the growth of cognition, free energy minimization, and the embryogenesis of, let's see, they cut off the title, cortical computation. So this is a comment on a paper, The Growth of Cognition. This is a paper, in their article on the growth of cognition, Wright and Bork present a compelling account of the emergence of cortical substructures from anti-natal network dynamics without external inputs and the subsequent postnatal development of these substructures as the network responds to complex visual stimuli. In order to supplement and hopefully strengthen their proposal, I will make one short general point and then proceed to propose specific future directions. The general point is that, as Wright and Bork discussed, their model dovetails nicely with the free energy principle. Therefore, I believe their model would benefit from conceptual and technical integration with previous work in the free energy principle literature on morphogenesis. And there's a Friston, of course, is involved in one of the papers here. and the emergence of synchrony in networks of mutually inferring neurons, Palacios. These have not been discussed nor referenced anywhere in the Target article, which I found surprising given their apparent relevance to the subject at hand. So then he gives his own model and analysis. So this is about like a developmental model of the brain. And it sort of follows the free energy principle. But what he's saying here is that he didn't really reference the free energy principle directly. And so for those of you who aren't like versed in the free energy principle, and I don't think any of us are, this is a newer theory that tries to describe what's going on in cognition and in the brain. And so this is actually the free energy, Jesse might actually talk about the free energy principle a bit in his literature review as sort of a new sort of approach, and maybe grounded in some of the cognitive science work. But I think, I think this is an interesting talk about what's going on. There are a lot of different papers on the free energy principle, and I think we've presented a couple in the group here, but I think it's, so this is just I think it's a good thing to visit and revisit and kind of get a handle on what's going on. I think this is a nice little response to this paper. I would look up this paper itself just to see. I don't know if I have a copy of it here, but this is something I ran across and I put it in the folder, and I wanted to go over it a little bit.
Yeah, I would like to talk more about the free energy principle, but I have to give credit to Anson. I think he knows it better than I do at this point. So I imagine we'll be talking about it as well. And I don't quite know, but I think it will come up in your term paper or something like that too, probably. But.
Oh, you might mention it in his paper, Anson.
Yeah.
Oh,
you seem to be muted.
Possibly. It might come up in like the artificial consciousness stuff I want to cover. I definitely am focusing on frontier research, so it would meet the criteria for that. With the limited time I have left in the semester, I don't want to be too ambitious, but it might come up in a cursory way.
Yeah.
Yeah. No pressure. More just kind of say anything that knows that pretty well.
Yeah.
At least better than I do.
So,
okay.
I wanted to mention, like, let's see, maybe, well, this I think is the original paper. So this is the growth of cognition for energy minimization and the embryogenesis of cortical computation. So this is the paper that they were referencing in that last note. And so that was a note about this paper. And so what is it about this paper that's interesting? This is actually a physics of life review. So this is, the free energy principle is really based in physics and in like, thermodynamics and that, but they're kind of applying it to the brain. And so it's something that's very mysterious maybe to a lot of people. There is in one of the Slack channels, and I can't remember which one, I think it was maybe myself or Jesse or Rashab who posted a thing about like how to learn the free energy principle without any math.
Yeah, we have a whole Slack channel about the free energy principle, and I think I put that resource in there. So if anybody's interested in that, please check that out and obviously bring it up here.
Okay, yeah, so there is a channel on this devoted to this topic. So this paper is, the abstract is the assumption that during cortical embryogenesis, neurons and synaptic connections are selected to form an ensemble, maximizing synchronous oscillation. So this is one of their assumptions here, is that there are these ensembles of neurons and connections that form these ensembles that maximize synchronous oscillation. And this actually goes back to people have thought about this idea for like decades, thinking about synchrony in the brain and how it's special and how it enables a lot of cognition. So this is not new. This is just a new way of viewing this topic. So the Synchrony explains mesoscopic cortical development and serves as a mechanism for cortical information processing. And so they talk about this network that emerges in development, and they talk about it in a dynamical systems, from a dynamical systems perspective. So they talk about this network that has stable and unstable fixed points. So you can look at something in what they call a phase space, and you can look at the how things exist in phase space. So there are these fixed points in the phase space where things are attracted to, and so that's true of these oscillations, which are sort of these dynamical systems that tend towards these fixed points. So you can have these types of places in phase space that are fixed or unfixed, or stable or unstable fixed points. And then there are these asymmetrically connected networks, which behave differently than that. Simulations of growth explain a wide range of anatomical observations for a columnar and non-columnar cortex. So we know that the neocortex has these cortical columns that are like the different layers, and there's processing up and down the layers. And then there's also cortex that's non-columnar, and they simulate this. Also superficial patch connections and the organization and dynamic interactions of neuron response properties. Let's see. So yeah, they basically get into all of this. So this is a model of how the brain grows during embryogenesis. And so they kind of get into the morphogenesis of the brain. So during embryogenesis, cortical neuron precursors divide and migrate. So what you have in the brain is you have these precursor cells to neurons that proliferate. They migrate to different locations, and then they start to differentiate into neurons, and then they start to connect later on. But they have these gap junctions in between them that allow them to sort of communicate and find their place in the brain, and then they start to develop connections between themselves, and then they form these networks. And so developing neurons become progressively elongated. Synapses connect neurons one-to-many in a sparse fashion, with few synapses formed for the number of contacts made between axons and dendrites. So there's a sort of connectivity where some cells are more highly connected than other cells. There are some cells that, they have connections to many different cells. And so that's what they're trying to describe here. This is something that we've described in our developmental AI work. We're using an agent in this case, but they're talking, I think, more about the human brain. And so this is very theoretical, but basically they're trying to understand what happens during embryogenesis. And so they're using this approach where they're talking about the brain, going from like these undifferentiated neurons to differentiated neurons to things that are connected together that form these networks. And so they get into a little bit of the history of this. So earlier models for embryogenesis were unable to provide any complete explanation of why columnar development, which is the development of these cortical columns, takes place before visual experience. Yet requires visual experience to maintain the organized pattern. So another thing about like brain development, at least in mammals or in humans, is that in neocortex, which is what they're talking about, oftentimes that the development of that is really dependent on experience. So sensory experience, like visual experience, really does shape how it's wired together. And so if you take away a sensory modality from a developing organism, like a developing rat, their neocortex will look much different than a rat that's been trained in a visual world. So sometimes they're able to they'll do experiments where they take the eyes out of rats very early in development, and then they allow them to grow up in the sensory world, so they just have their sense of smell and their sense of hearing, and they're able to, and then they look at the cortex, and the cortex actually looks quite different. Most of the visual area is taken over by projections from the auditory areas and the olfactory areas. And so this is an attempt to explain a lot of this sort of stuff. So this gets pretty deep into the world of the free energy principle, and they talk about these Markov blankets, which again is something that we have a tutorial on in the free energy principle channel. There's a new one by Carl Friston. I think it's like, I like my warm Markov blanket or something like that. So, I mean, this is pretty intense stuff, but I encourage you to read about the free energy principle a bit more. We have this channel devoted to it, so that's there. And then I think I'm going to stop with the papers today, but I will make a couple of announcements here.
Could I ask what the name of the paper was that you just presented?
Oh, this one is, so this one was The Growth of Cognition, Free Energy Minimization, and the Embryogenesis of Cortical Computation.
By Wright and Berg.
Yeah.
Okay.
And,
all right, thanks.
Then this
I
one
know it'll be available in the...
Yeah. And then this one is a comment on it, Beyond Connectionism. And then this, so there, the free energy principle idea is sort of moving beyond just connectionism, talking about like free energy and thermodynamics, along with like sort of, we're talking about connected neurons, but it's not connectionism as we typically think of it. And so that's I was going to make a couple announcements here, though. One of them is for this, and I put this in Slack, that there's this conference the Center of Open Science is putting on. This is for the first annual unconference addressing open scholarship for education. And so they're looking for unconference sessions, workshops, lightning talks on, I think the idea is basically that it's open education on, like internet-based education. Basically what we're doing here, virtual lesson planning, all that sort of stuff. So it's maybe an opportunity to advance some of the things that we've been talking about with respect to the cyber cafe proposal, and maybe some other things along with like the stuff that Jesse's working on. It might be a good venue for that. We'll talk about that more in the coming weeks. If you're interested, the deadline for submitting something, I think, is December 18th. So we have a couple weeks to think about that. And then the event itself, I think, is in February. But that's something we can talk about later if you're interested. I put a link to this in Slack in one of the channels. Another thing is this tweet from Maxim Roginski, where he was reading, I think it was Daniel Dennett, one of Daniel Dennett's books, and he found this passage in it. And he said, this is not accurate. McCullough and Pitts never talk about training or learning. This is, in fact, one of the targets of Rosenblatt's connectionist critique of the McCullough and Pitts framework. If you want to represent a new concept, you'll need to design a whole new net de novo. And I guess the idea is that, like, if the McCullough-Pitts neuron was the original model they were talking about. And the idea was that this is like sort of the birth of connectionism. The idea that you can have these neurons that are, you can have like a bank of neurons as inputs, and you map them to a hidden layer, and you map them to an output layer. And then you can actually learn patterns using that type of architecture. And I guess the thing that I guess maybe Dennett's, and this might be just to make this accessible to a general audience, but the thing he's kind of suggesting is that you can learn things in this architecture, and it doesn't matter what it is. And so what he's saying, Maxim is saying here, is that you don't actually have, you can learn one concept that way, but if you want to learn a new concept, you have to either design a new network or forget everything you learned before and learn a new thing. And so that's one of the things I think maybe even is a sort of a stumbling block for a lot of connectionist AI, is this idea that, you know, how much can you learn and how much can you generalize from that? And can you learn like one thing and then learn something else and, you know, have it be like sort of independent from one another? And so this is I think it was an interesting thing that he pointed out here. Not that I have any really strong insights into this, but I just thought it was an interesting distinction here.
Yeah, I saw that and I had wanted to bring that up. So I thought that you did.
Yeah, I mean, yeah, it's again food for thought, and if you have any ideas, you know, we can talk about it in Slack. Finally, this thing that I think Rashab posted in Slack about the British Neuroscience Association. They have a call for proposals, so this is something that's off into the future a bit. Proposal deadline is January 20th, and this is for the British Festival of Neuroscience. I think it's online. It's virtual, so it's something that if you live anywhere in the world, you can participate in. But this is something that if you have something you want to present or ideas we might, engage in, we should start thinking about it now. And again, these are opportunities that, I'll present opportunities in the meetings, and if we want to follow up on something and submit something, then we're welcome to do it. And that's how we get things. That's how we get exposure. That's how we get things, moving.
Yeah, anybody who has any ideas for events, like, there's something that I saw, or like at my university, or I saw this on Twitter, or I saw this whatever. Please, we have a channel for that in Slack, but I mean, you can post it anywhere. Just put it in general, or let us know, because we're always looking for stuff like that. And I think that's. And one thing for those who are new to this lab or looking at it, there are a lot of opportunities to sort of take a project and run with it and find, if you're really excited about like that thing, the British Neuroscience Festival, you could easily, find a submission and find some people here in the lab who are interested in those things and help you write a proposal for it and present something or whatever. I think that's one of the benefits of the situation. And sharing those ideas for opportunities are always encouraged. So.
Okay. So anyone else have anything to say before we leave for the week?
Could you share that the Gaussian data thing in Slack or something? That seems more relatable. The fMRI data and those things are kind of relatable, so I just thought I could read about that this weekend or something.
Okay. Yeah, I'll share that in Slack. Yeah.
And the whole folder, too, would be good. You can maybe hear in the thing or in Slack, too.
Okay, that sounds good. Yeah, I put it in the chat, but I can put it in Slack. It's always good to be redundant on that. People can get to it wherever. Gabrielle, Anson, do you have anything to add?
As of right now, no.
No, not at the moment.
Okay. Well, thank you for attending, everyone. Again, we had a pretty good meeting. If you have any things you want to talk about during the week, put them in Slack, in any one of the channels will do. Probably general is fine for most things, but like for the free energy principle, we have a channel, and for other things. So otherwise, have a good week and talk to you soon.